Dear students. Class 8 Chemistry. Myself Zainab Bohri. Today we are going to continue chapter number 8 Water. Part 4. In today's video, we will discuss water of crystallization, chemical properties of water and hard as well as soft water. Let us see what is meant by water of crystallization. Water of crystallization is the fixed amount of water associated with crystals that forms an integral part of the crystal. It means fixed amount of water which is in a loose chemical combination with one molecule of a salt in its crystal form. For example, crystallization of sodium acetate you can notice here in this figure. Observe this figure which is showing structure of copper 2 sulfate, that is CuSO4.5H2O. Here in the crystals of copper sulfate you can see the copper sulfate molecules and loose water molecules. Dear students, always remember when we heat such crystalline salts, then they loses their water of crystallization, and with this they also lose their characteristic color. They forms amorphous powder of that salt. Here are some of the salts in their hydrous crystal form. First, gypsum salt, blue color crystals of blue vitriol, that is copper sulfate. Green vitriol, ferrous sulfate. White vitriol, which is zinc sulfate in its hydrated crystalline form. Epsom salt, that is magnesium sulfite. Goethals salt, that is sodium sulfate. Dear friends, crystals. Crystal means the homogeneous solids which have definite geometrical shapes and their particles are arranged in a specific symmetric order. The process of crystallization by which crystal of substance are separated by cooling its hot saturated solutions. Let's discuss now here some important phenomenon with examples. Efflorescence is the property of spontaneously releasing the water crystallization to the atmosphere. For example, washing soda, when it is kept in the atmosphere, it loses its water of crystallization and forms amorphous white colored powder. Next is hygroscopic substances. Hygroscopic substances are the substances which absorbs water vapor from the atmosphere, and this phenomenon is known as hygroscopy. Example of this is concentrated sulfuric acid, phosphorus pentoxide, anhydrous calcium chloride, and silica gel. Pocket of silica gel we can see in various articles like bottles, cameras, lenses, shoes, etc. Since they have the capacity to absorb moisture from the air, which keeps all these articles safe from the effect of moisture. Next is deliquescent substances. Deliquescent substances absorbs water vapor from atmosphere to such an extent that a saturated solution is formed by this absorption of water. For example, caustic soda, that is NaOH, magnesium chloride, MgCl2, calcium chloride, and so many salts are there. Desiccating agent or drying agents are the substances which remove moisture from the substances in a physical change. And dehydrating agents removes water molecules from the substances in form of chemical changes. Let us observe a video.
A hydrate is a chemical compound that contains water as part of its crystal structure. This water is called the water of crystallization. Most hydrates are stable at room temperature. However, some salts such as sodium carbonate decahydrate spontaneously lose their water of crystallization to the atmosphere. This is known as efflorescence. The efflorescent substances lose their water of crystallization either fully or even partially. After losing the water molecules, they crumble into a powder. Epsom salt is another chemical which shows the property of efflorescence. Therefore, when magnesium sulfate heptahydrate is exposed to dry air, it becomes a monohydrate. As air absorbs more water with rising temperature, any increase in the temperature will result in higher rate of efflorescence. Something interesting happens when concentrated sulfuric acid is exposed to humid air. It increases in volume. This happens because concentrated sulfuric acid is able to absorb water vapors from the atmosphere. By doing so, it becomes dilute and its volume increases. Such compounds which can absorb moisture from the air to become hydrated are called hygroscopic. You must have seen that many optical and electronic items are packed with small pouches of silica gel. Do you know why? Well, silica gel is made from sodium silicate, Na2SiO3. This compound is also hygroscopic and absorbs moisture from the air. In this way, it serves as a drying agent and protects the electronic devices against the atmospheric humidity. Some other examples of hygroscopic substances are quicklime and phosphorus pentoxide. These chemicals may also be used for drying gases in the laboratory. Have you observed what happens to the dry instant coffee powder that accidentally gets spilled on the table? Well, after some time, the powder becomes a sticky liquid. This happens because the dry coffee powder is also capable of absorbing moisture from air. However, in this case, the solid coffee powder absorbs water and becomes a liquid. Now observe what happens when anhydrous calcium chloride is exposed to the atmosphere. This solid absorbs moisture from the atmosphere and forms a saturated solution. Such hygroscopic substances that absorb water vapor from the air and undergo a change of state by dissolving in that moisture are called deliquescent substances. This process is called deliquescence. Some other examples of deliquescent substances are zinc chloride, ferric chloride, zinc nitrate, copper nitrate, caustic potash, caustic soda, calcium chloride, and magnesium chloride. Note that deliquescence is minimized during dry conditions. This is because deliquescence takes place only when the vapor pressure of the salt is much lower than the atmospheric vapor pressure. Sometimes on exposure to air, table salt or sodium chloride also turns moist and ultimately forms a solution. Actually, pure sodium chloride does not show deliquescence. However, in the presence of impurities such as magnesium chloride, it becomes deliquent. The hygroscopic substances such as silica gel, phosphorus pentoxide, and quicklime are also called drying agents or desiccating agents. The desiccating substances remove moisture from other substances by absorbing the moisture themselves. However, there are some other substances that cause loss of water molecules from other substances. These are known as dehydrating agents. One example of a dehydrating agent is concentrated sulfuric acid. It removes all water from sugar and converts it to a black spongy mass called sugar charcoal.
Dear students, I hope you understood all the definitions with their examples. Let us move to the chemical properties of water. Water is a neutral to the litmus test. Normally, water is neutral. It means it is not showing any change in color of litmus paper. When water is decomposed thermally, the molecule of water breaks down into hydrogen and oxygen gas. This is taking place at the very high temperature, about 2000 degrees Celsius. On electrolysis of water, also we can get hydrogen and oxygen gases. Here, acidulated water is said to be into the electric current, which decomposes it electrically into hydrogen and oxygen gas. Here are few more important properties are as steam reacts with coke to form water gas. Dear friends, water gas is an important fuel in the different industries. Water reacts with non-metallic oxides and forms acidic solution. Purity of water can be tested by simple test like on heating up to 100 degrees Celsius, pure water converts into the gaseous state. It means it starts to boil. Let us observe reaction of water with metals in the electrochemical series. Potassium. Potassium reacts with water violently with sparks or explosion and releases hydrogen gas, while that of sodium reacts violently with the releasing phase of the gas hydrogen. Often it burns with an orange flame. Calcium reacts vigorously, creating small fields and bubbles appear of hydrogen gas. Lithium also reacts vigorously, creating fields, and it floats vibrantly on the surface of water, and it slowly disappears, leaving behind lithium hydroxide and hydrogen gas. Magnesium reacts with hot water or steam to give magnesium oxide and hydrogen gas. Aluminium reacts with hot water and steam. It gives aluminium oxide and hydrogen. Zinc, iron, lead also reacts with steam of water to give their respective oxides. Here, note down copper, silver, gold, platinum, like less reactive metals, do not react with water.
Let us observe all properties.
Properties of water. Water is neutral. It does not change the color of the litmus paper. When water is strongly heated above 2000 degrees Celsius, it decomposes into hydrogen and oxygen gases. Water can also be decomposed into hydrogen and oxygen by passing electricity through it by a process called electrolysis. When water in the form of steam comes in contact with a coke, it produces water gas. Water gas is an important industrial fuel. Chlorine gas dissolves in water easily. It reacts slowly with water to give hydrochloric acid and hypochlorous acid. The aqueous solution of chlorine is called chlorine water. When it is exposed to sunlight, it releases oxygen gas. This makes chlorine water a very good bleaching and sterilizing agent. Several non-metallic oxides also dissolve in water to produce acidic solutions. Let us learn a few common tests for water. The easiest test for water is to measure its boiling point. If it is pure water, then it boils at 100 degrees Celsius. Another interesting test is to pour some water over anhydrous copper sulfate crystals. The white-colored crystals get hydrated and turn bright blue. You can also test for water with the help of cobalt-2 chloride. In presence of water, the blue-colored cobalt-2 chloride crystals get hydrated and incorporate water molecules in their crystal structure. This changes the color of the crystals to pink.
Dear friends, let us move to the next concept, hard water and soft water. As you know, the water present in different natural sources has different substances dissolved in it. It has been found that water drawn from certain sources forms a lather with the soap very easily, and such water is known as soft water. On the other hand, water obtained from some other sources does not easily form a lather with the soap. Rather, it forms a sticky scum or a precipitate. This water is known as hard water. Let us study in detail about hard and soft water. Hard water is of two types. First, temporary hard water. Water which has bicarbonates of calcium and magnesium dissolved in it is known as temporary hard water. This kind of hardness can be easily removed by the process of boiling. Second is permanent hard water. Water which has sulfates and chlorides of calcium and magnesium dissolved in it is called as permanent hard water. Dear friends, This hardness cannot be removed by simple boiling process. Let us observe in detail temporary hard water and permanent hard water.
Rain is the natural source of water. Rainwater is naturally soft. But as rainwater flows through the rocks and the groundwater reservoir into our waterways, it collects and dissolves the elements like calcium and magnesium. The water with dissolved calcium and magnesium salts is called hard water. Soft water can be used for consumption. Soft water forms a rich lather with soap and can be used for cleaning purposes. Hard water forms a sticky precipitate with soap in place of lather. Thus, it cannot be used for consumption or cleaning purposes. Hard water is softened for household or industrial usage. The method of softening hard water depends on the type of hardness of water. There are two types of hard water, namely temporary and permanent.
Disadvantages of hard water. Too much hard water is not safe for drinking. But little hard water is good for drinking as it provides a taste to water along with essential minerals dissolved in it. More hard water is not fit for laundry as it causes wastage of soap, as well as hard water leaves a substance at the bottom of the container when it is boiled. This substance is called as scale or fur, which damages the container. Hence, it is not good for broilers and in industry to use hard water. Hard water is not suitable for leather and textile industries. Clothes do not take dyes uniformly while printing them using hard water. Hard water is not very good for cooking as well. Let us see how to remove hardness of water.
Hardness can be removed by boiling. Let us boil the hard water and see what happens. On boiling the temporary hard water, calcium and magnesium bicarbonates decomposes to form insoluble carbonate precipitates. These precipitates are removed by filtration, making the water soft. Permanent hardness is removed by treating water with sodium carbonate. Let us add sodium carbonate to this water and see what happens. On adding sodium carbonate to permanent hard water, sodium reacts with chlorides and sulfates and forms insoluble carbonates as byproducts. These precipitates are removed by filtration. The water thus obtained is soft and safe to use.
Dear friends, must solve exercise 2 as well as question number 1 and 2 from exercise 3. Thank you very much.